Upon completion of this lesson, you will be able to identify and describe the principal components of the landing gear system. The aircraft has a conventional tricycle landing gear consisting of a nose gear and two main gear assemblies. Each main gear comprises an oleo shock absorber and dual wheels with disc brakes. The nose gear is also a dual wheel with an oleo shock absorber and is steerable. The landing gear assemblies are operated by pressure from the right hydraulic system, and the landing gear doors open and close automatically. Extension and retraction is controlled by the handle on the center instrument panel. Lights above the handle indicate the position of the gear. Each gear assembly has a green safe or a red unsafe light. The gear door open light will come on when one or both main gear doors are not closed. The emergency extension lever is located on the right side of the pedestal. It's used for free fall of the landing gear. This is required if the hydraulic system or normal extension fails. This is covered in the lesson on malfunctions. Here is a close-up in extended position. The nose wheel steering system is controlled by the nose gear steering wheel and/or the rudder pedals. Nose gear steering is powered from both the left and right hydraulic systems. A set of toe brake pedals are fitted to the rudder pedals, so that both pilots can operate the main wheel hydraulic brakes. The brakes are assisted by an anti-skid system to obtain optimum braking under all conditions. Ground shift mechanism changes various systems from ground mode to flight mode and vice versa, with the extension and compression of the nose gear shock strut. It also prevents gear retraction on the ground and nose wheel steering in flight. Yes, yes. Yes, yes. Good. Well done. Done. Correct. Correct. Each main wheel assembly consists of an oleo shock strut and dual wheels with disc brakes. A vibration damper on the torque links prevents twisting vibrations. On wet or slushy runways, main gear spray deflectors between the wheels prevent spray being thrown up into the engines. Each main gear assembly is attached to the rear wing spar and is supported by side brace links. An actuating cylinder is attached to the wing structure and to the gear strut. When the down position is selected, gravity and the actuating cylinder will push the gear into the down position. A hydraulically operated bungee cylinder, assisted by two springs, then locks an over-center linkage, which in turn secures the side brace linkage, locking the gear in place. When up is selected, hydraulic pressure overcomes the tension of the bungee springs and unlocks the over-center and side brace linkages. The gear is then retracted by the actuating cylinder and held in position by hydraulic pressure. When hydraulic pressure is reduced during climb, the main gear will drop down and rest on the mechanically locked inboard doors. There are no main gear up locks since the gear is held up by the doors. Each main gear has a large hydraulically operated inboard door and a smaller mechanically operated outboard door. The inboard doors open during gear travel and close at the end of each travel cycle. When closed, the inboard doors are held up by an uplock hook. The main gear doors remain closed by a mechanical spring-loaded detent. The doors can be pulled down and opened when the hydraulic system is depressurized. The outboard doors are mechanically linked to and move with the shock strut. They remain open when the gear is extended. A tail bumper on the bottom of the aft fuselage acts as a shock absorber to protect the aircraft structure in case of a tail strike. An indicator on the bumper shows if the bumper shock strut has been compressed from ground contact. Here it is in the normal horizontal position. And here the indicator shows that the bumper shock strut has been compressed from ground contact. Good. Good. Yes. Yes. The nose gear assembly retracts forward into the wheel well. It consists of an oleo shock strut, dual wheels and a steering mechanism. The shock strut is attached to the nose gear housing and is supported by side structure braces and drag links. An actuating cylinder connects the aircraft nose structure and the shock strut. The nose gear also has a spray deflector. When selecting gear down, a combination of gravity, aerodynamic forces and hydraulic pressure will push the nose gear into down position. The nose gear also has a hydraulically operated bungee cylinder, which locks the over-center linkage, securing the drag links and locking the gear down. When the gear is retracting, hydraulic pressure unlocks the over-center linkage and folds the drag links. When retracted, the gear is again locked by the over-center linkage. The nose gear wheel well enclosure consists of 2 forward and 2 aft mechanically operated doors. The 2 forward doors are mechanically linked to the nose gear, so that they're open during gear transition and closed after each cycle. 2 aft doors are also mechanically operated and open when the gear is down. A ground shift mechanism, actuated by compression and extension of the nose gear shock strut, changes various systems from ground mode to flight mode, and vice versa. 2 micro switches actuate 2 ground control relays, which in turn affect many of the aircraft systems. They're energized on ground and de-energized in flight. For instance, nose wheel steering will function on the ground, but is centered and locked in flight. The rudder pedals are connected to the nose wheel steering on the ground, but disconnected in flight. A mechanical interlock prevents gear handle retraction on the ground. To prevent unintentional retraction of the landing gear on the ground, landing gear pins can be inserted through the over-center links. The pins are stowed on the flight deck behind the left pilot. Well done. Good. Well done. The landing gear indication and warning system gives visual and audible indications of safe or unsafe positions of the landing gear and doors. The gear handle controls the hydraulic system that operates the gear. Each gear assembly indicates either a green safe light or a red unsafe light. The main gear door open light will come on when one or both main gear inboard doors are not fully closed. When selecting gear up, the green lights will go out and the red gear unsafe lights will be on while the gear is in transit. The lights will go off when the gear is retracted. When selecting gear down, the red lights will come on while the gear is in transit and turn to green to indicate when the gear is safely down. For safety reasons, each green safe light has 2 bulbs, each connected to a different electrical circuit. The emergency extension lever is located under an access door between the right pilot seat and the pedestal. It mechanically releases the main gear door latches, nose gear over center lock and places the gear hydraulic system in bypass, allowing the gear to free fall and lock. Note that the main gear doors will remain open after extension. It may take a while before the green safe lights come on. The gear warning horn sounds if landing gear is not extended, below 1200 feet radio height and airspeed below 210 knots, with either throttle close to idle. The gear horn off button allows you to silence the warning. However, if the flaps are extended beyond 26 degrees with landing gear not safely down, the warning horn will also sound. Under these conditions, it cannot be silenced by the gear horn off button. This warning is independent of altitude. The landing gear limitations placard is placed on each pilot's instrument panel, below the nav display. The maximum speed with landing gear extended is 300 knots, or Mach 0.70. Maximum speed for gear retraction is 250 knots. System tolerances may dictate a slower speed for positive gear retraction. Gear operation is not possible with low hydraulic pressure of 1500 psi. It must be the high 3000 psi. Good. Yes.